Hi, everyone. I'm Professor Ladilia Jordan, and today we are going to look at how analysts use data to make decisions when there is more than one possible outcome. A regression model gives us a prediction based on a particular set of input values. The prediction is important, but managers usually have more questions. They want to know what happens when they change a decision, and they want to understand how much the results could vary. We're going to cover two tools. The what if analysis helps us test specific choices. And then the Monte Carlo simulation, it helps us explore the many possible outcomes when the inputs vary. Uh, the big thing for today is that prediction is only the starting point. We still have to interpret the prediction and decide what action makes sense for us. What should we do with the data? What decision do we need to make? All right. So by the end of this, um, first, you should understand how the regression equation produces a predicted result. We need that foundation because both of the decision tools that we're discussing use the same equation that we get from our model. And then we'll look at the what if analysis and scenario manager. And these tools let us enter specific values and see how the prediction changes. Then we'll move into the Monte Carlo simulation. And that simulation is going to allow the inputs to vary across many trials, which will give us a range of possible results. And by the end, you should be able to look at a scenario summary, a histogram, and a simulation statistics, and explain what those outputs mean for a business decision. Okay, so why do analysts spend time exploring possible outcomes? The first reason is to compare options. A business may have several choices available, and each choice may affect the results differently. And then the reason is uncertainty. Sales, customer demand, costs, staffing, and many other business inputs change over time. We need a way to reflect that variation in the analysis. And then the third reason is risk. Managers need to understand how widely results could vary and whether low outcomes are possible. And then the last reason is action. The analyst should lead the analysis. It should lead to a recommendation or help someone decide what to do next. And remember, one prediction gives us one expected result. Exploring possible outcomes, it'll give us a fuller picture of the decision. So there's three questions that analysts try to answer. We want to know, what do we expect? The predictive model answers that question. It gives us the estimated outcome using a starting set of input values. It's just the starting point. And then the second question is, what happens if something changes? And that is where the what if analysis comes in. We select a specific change and calculate the new prediction. And the third question is, what range of outcomes is possible? And that's where the Monte Carlo simulation comes in. It answers that question by allowing the input values to change across many trials. These outputs, they give us different information. And the baseline, which is when we made the initial prediction, It tells us where we are starting. The scenarios, they help us compare the decisions. And simulation, it helps us understand variation and uncertainty. Now, here we're going through the decision analysis process. We start by defining the decision questions. We need to know what the business is trying to decide before we can begin working with the data. And then we build or use a predictive model. Um, and for our example, we're going to be using a multi-regression equation. And then we establish a baseline. The baseline is a starting point that we will use for our comparisons. After that, we're going to test the selected scenarios. We may change one input or several inputs depending on the decision. And then we simulate uncertainty by allowing the input values to vary. And the final step, it's for us to interpret the evidence, interpret our results, and then recommend some action. And each part of the process is going to support the next process. Now, today in this video, we're going to use a fictional business example. We're going to use bright space workshops. Um, and it's just something that I made up, but we're going to use it for our example. So, Brightspace, it provides professional workshops. The company wants to understand how the number of registrations and the amount spent on marketing affects monthly revenue. And in this case, monthly revenue is the outcome that we want to predict. Registrations and marketing spending, those are going to be our input variables. And the business question is which strategy could increase predicted revenue and how much uncertainty surrounds the prediction. And of course, this is something that I made up, so this company doesn't exist, but the same process applies to many situations, and a business could predict costs, sales, staffing needs, customer demand, production value, or another numeric outcome. And we're going to use this bright space example throughout um, our lesson today, and it'll help you see how the steps work together. So, uh, for here, we're going to pretend that we already ran our model. And so, excuse me, we've already ran our model. And see, so we already know what our intercept is, what our registrations coefficient is. We know the marketing coefficient because we've already done that and created our model and ran it for this example, okay? So the first three values we see come from the regression model. The intercept is 4,800 and the registrations coefficient is 85. Marketing coefficient is 2.40. And these values, those three values here, they're going to be used to create our prediction equation for monthly revenue. And then we have the mean registrations. The value is 165 and mean marketing spending is 7,500. Those values represent the typical input values, and we will use those values to calculate the baseline prediction. Now, for the registration scenario, um, we're going to be increasing our registrations to 185 when we go through our what if analysis. And we're also going to look at what happens when we increase our market spending to 8,700. And these values are going to be entered into the model to compare the two possible decisions. Now, the simulation mean of $36,840 represents the average predicted revenue across simulation trials. This is when we're working with the Monte Carlo. The simulation standard deviation of $2,650 describes how widely those predicted values vary around the average. And together, all these values support the baseline calculation, the scenario comparison, and interpretation of uncertainty. Now, just remember that for this example, we're going to pretend like we've already ran our regression model and we've already come up with these values that we see here, the 4,800, the 85, and the 2.40. We have our intercept, we have our registrations coefficient, and we have our marketing coefficient. All right, so before we work through the equation, we need to understand the role of each variable. The outcome variable is the value the model was trying to predict. In this example, that was our monthly revenue. The input variables are the values used to create the prediction. BrightPath uses registrations and marketing spending. Registrations are a count. We can count the number of people who registered, and marketing spending is a dollar amount. It can include dollars and cents. The basic flow is inputs go into the model and the predicted outcome comes out. And later, these input values will become the changing cells that we use in our scenario manager and the randomly generated values in our simulation. All right. So, again, talking about regression, regression is our prediction engine for everything we're doing. The regression equation, it's going to take our input values, apply the intercept and coefficients, and calculate the predicted monthly revenue. The scenario manager, it's going to use this equation and it's going to change the input values and allow the formula to recalculate. Now, the Monte Carlo simulation, it's going to use the exact same equation, but many times. In each trial, it's going to use a different combination of input values. And the equation produces a predicted outcome for each combination. Now, the regression model stays the same throughout the analysis. The values going into the model are what changes. This way, this is why we need to run the regression and and correctly identify the intercept, the coefficient and coefficients before we can begin our what if analysis or our Monte Carlo simulation. Now, what you see here is how we come up with our regression equation. So, remember that the predicted outcome that we're looking for here is our monthly revenue. The intercept is 4,800, and the intercept is the starting value in the equation before the input um, contributions are added. So, what you do is you take your monthly sales, it's going to equal your intercept plus um your units sold. The coefficient for registration is 85 for every registration entered into the equation. And so we multiply our value by the coefficient. Um, let's see. Our numbers that we're trying to have by the coefficients. Um, so the coefficient for marketing is 2.40. So we're going to multiply the marketing by 2.40. And we're going to add all these pieces together. So the equation is 4,800 plus 85 times the number of registrations um plus 2.40 times our spending budget. So in Excel, the formula will use cell references for the input values and fixed references for the coefficient. And don't worry, after this, I will go through a complete demo. I just want you to kind of understand it first. So, the coefficients tell us how each input is related to the predicted outcome. The registrations for our example, the registration coefficient is 85. That means one additional registration is associated with an $85 increase in predicted monthly revenue when the market spending remains constant. And the marketing coefficient of 2.40 means that one additional dollar of market spending is associated with a $2.40 increase in predicted monthly revenue when registrations remain constant. So, in this case, both coefficients are positive, so increasing either input moves the predicted revenue upward in this example. N- Now we need a baseline. A baseline is the starting condition we will use to compare the scenarios. In this example, we are using the mean values from our sample of data. And the mean number of registrations is 165. And the mean marketing is 7,500. So we enter those values into our regression formula. And the result is the baseline predicted monthly revenue, which is 36,825. So we take our intercept, which is 4,800, multiply it times our coefficient of 85 times our mean number of registrations plus our coefficient for our marketing and multiply it for by our mean marketing spend. And this is our regression equation here. And our baseline predicted monthly value revenue is our 36,825. Okay, now we're moving into the first decision tool, which is the what if analysis. The question changes from what do we expect under the baseline like, for our default prediction to what happens to when we make a specific change. And we're going to select exact input values. We're going to calculate the new prediction, and we're going to compare it with the baseline. And because we choose the values, each what if scenario represents a defined decision or a planned alternative. Now, a what if analysis changes one or more input values and recalculates the predicted outcome. That's what a what if analysis is. What if this changes? What happens? So, you as the analyst, you decide which input to change and what value to test. In this example, the baseline number of registrations is 165, But we want to test what happens when the registrations increase to 185, about 12%. Market spending stays at the baseline value, so we're only changing registrations in this scenario. The regression equation then calculates a new predicted monthly value. And this gives the company an estimate of how the proposed increase in registrations could affect revenue. So, a what if analysis produces a specific answer for a specific set of values. Now, the what if process has four basic steps. First, we select the input we want to examine. What do we want to change? Second, we enter the proposed value. Third, we allow the prediction formula to recalculate. And finally, we compare the new result with our baseline. And the comparison is the part that gives the scenario meaning. A new predicted revenue value is more informative when we can explain how it changed from the starting point. So, did it increase our monthly sales? Did it decrease our monthly sales? How much did it increase? And we can repeat this what if analysis for several alternatives. And each alternative uses the same regression equation, which keeps the comparison completely, consistent. So we choose our inputs we're going to change, we change it, we recalculate, and then we compare the outcome. Now, there are a few common tools in Excel that we can use for the what if analysis. And each one answers a different type of question. The scenario manager, it compares defined alternatives, and we can create named scenarios, enter proposed input values, and compare the results. And then another tool in Excel is Goal Seek. And Goal Seek starts with a result we want to reach. It's like going backwards from the scenario manager. And Excel then calculates the input value needed to reach that target. And then we have the data table, which evaluates a range of values. And it's helpful when we want to see many possible results without creating a separate name scenario for each one. Here, we're going to focus on the scenario manager because we want to compare specific business alternatives. So, depending on what your needs are, you may choose a different tool. But today we're going to be going through the scenario manager. Now, the scenario manager, it stores different sets of input values. For example, we may create a scenario called increase registrations and another called increase marketing. Each scenario contains the input values connected to that option. Excel temporarily places those values into the changing cells and recalculates the prediction formula. Once the scenarios are created, Excel can produce a scenario summary, and the summary places the current values and the scenario values next to each other for us to compare. It allows us to see which inputs change and what predicted result each change produced. So, the scenario manager, it uses the equation that is already in the worksheet. And this is an example of what a scenario summary looks like. Now, the distinct changing cells and results cell. The changing cells are going to change, those are going to be our inputs. And in this example, those cells hold the registrations and the marketing spending. And the results cell contains your prediction formula. That cell calculates predicted monthly revenue. The scenario manager, it's going to replace the values in the changing cells, and the results cell then updates because the formula refers to those inputs. So the changing cells are the values being tested, and the results cell is the value we are measuring. When this setup is reversed, the scenario summary it won't work correctly. Always confirm that the inputs are selected as changing cells and the prediction formula is selected as your result cell. So, um, current values versus scenario values. Current values are numbers already stored in the worksheet. They usually represent the baseline. In this example, the current registration value is 165. Scenario values are the proposed values stored in a named alternative. The registration scenario uses 185 registrations. The difference in the input is 20 registrations. Um, More importantly, the difference is the change in predicted revenue. We want to know how those additional 20 registrations affect our outcome. Did our monthly sales go up? Did they go down? By how much? And this is why we calculate the baseline first. The baseline allows us to explain the estimated impact of our proposed decision. Now, the scenario summary places each option in a separate column. The current values column shows the baseline inputs and baseline prediction. This is where we started. The increased registrations column changes the registrations to 185 and keeps market spending at 7,500. Um, the increased marketing column keeps registrations at 165 and changes the marketing spending to 8,700. Um, $8,700. And at the bottom, we see the predicted values for each set of income inputs so we can easily compare them because they're side by side. So you need to read down the scenario column first, identify your input variables, values here, and then look at your resulting predictions. Then we compare across the columns to see how each option differs from the baseline and from the other scenarios. So, what changed and how did it affect our predicted result? Now, we need to compare our predicted results. So the baseline predicted value was $36,825. That's an increase. But hold on. The registration scenario, it produced $38,525. That's an increase of $1,700 over the baseline. Now, the marketing scenario, it produces predicted revenues of $39,705. That's an increase of $2,880 over the baseline. So, just looking at these numbers, The marketing scenario, it looks like it's the best scenario. But wait, we need to think about the cost of creating each scenario. Increasing marketing requires an additional 1200 in spending. Increasing registrations may require additional staff, materials, or space. So this predicted number, it's only one part of the decision. Now, um, when we're making the decision and choosing between the different scenarios, we need to first look at how much improvement does each option predict. Then we look at the option costs. For example, how much more are we spending to get that option? Third, is the option feasible? The company needs enough staff, space, time, and resources to support the change. Is this something we can really do? And then, does the option address the actual business need? The largest predicted revenue may look good, but the company still needs to evaluate the resources required to achieve it. It's great that it's the best scenario, but if we don't have the budget to do it, we can't do it. Um, so a recommendation, it should explain why the selected option makes sense for the business. It should include the predicted result and have considerations connected to that result. Now, scenario manager works well when we have defined alternatives to compare. It uses the same model for each option, produces repeatable results, and creates a report that's easy to communicate. Its limitation is that it only evaluates the values we enter. The registration scenario uses one registration value, and the marketing scenario, it uses one marketing value. Actual business conditions may take on many other values. So the scenario manager, it doesn't tell us how often an outcome may occur or how widely results may vary over time. And to examine a larger range of possible input combinations, we need a simulation. We need something that's more automatic. Now, business inputs rarely remain at one exact value. Registrations change from month to month because demand changes. Marketing spending may change because of campaign timing, the budget, adjustments to the budgets, and you may have unexpected expenses. The baseline represents a typical value, but actual observations may fall above or below our baseline value, our starting point. So when inputs change, the predictions changes too. This is the reason we move from the fixed scenarios and into simulation. Simulation creates many possible input combinations and calculates the predicted outcome for each one. And the output gives us a picture of the variation that may occur across many possible situations. Now, variability means that values naturally differ. For example, BrightPath, our fictitious company, they may have 150 registrations one month, 172 the next month, and 160 the month after that. Those differences represent variability. Now, uncertainty means we don't know that exact future value before it occurs. We know registrations vary, but We don't know the exact number that will occur next month. So simulation uses information about the center, um, like our mean, and the spread, which is our standard deviation, of the past, and assumed values to represent the uncertainty. Now, the simulation, it doesn't predict one guaranteed future. It creates many plausible combinations so we can examine the overall pattern of possible results. Okay, so now let's move into our Monte Carlo simulation. And we're going to shift from selected scenarios to repeated trials. And each trial uses a possible um, combination of input values and produces one predicted um, outcome. Now, after we repeat the process many times, we can study the distribution of the results. And this gives us information about the expected outcome, the spread of the outcomes, and the possibility of lower or higher results. Now, a Monte Carlo simulation repeatedly generates possible input values and calculates a prediction for each set of values. The input values are generated using defined assumptions. And here, those assumptions include the mean, the standard deviation, and the variable type. The simulation may run 1,000 trials. Each trial produces one predicted monthly revenue value. And when all of the trials are complete, the predictions form a distribution. And the distribution gives us more information than one fixed result. It shows where the predictions are concentrated and how widely they vary. The randomness represents uncertainty within the limits of the assumptions we entered. Now, the Monte Carlo simulation follows the same cycle over and over. First, we generate a possible value for each input. Then we insert those values into the regression equation. And then third, we calculate and record the predicted outcome. Then we repeat those steps in the next trial. So in Excel, each row is going to represent one trial, and the formulas create possible input values and regression, and the regression formula, it calculates the outcome. So after filling the formulas through all the cells, we have a large set of simulated predictions, and we then summarize and visualize those predictions so we can interpret the pattern. Now, the variable type affects how Excel should generate simulated values. A discrete variable is countable and normally uses whole numbers. Registrations are discrete because we count people. Um, we don't normally have 165.7 people or registrations. Now, a continuous variable can take values across a range or may include decimals. Marketing spending is continuous because the amount can include dollars and cents. Now, the simulation formulas need to reflect the differences. A discrete formula should return whole numbers. A continuous formula may return decimal values. Selecting the correct value type helps the simulated data represent the real world variable more accurately. Now, mean and standard deviation. The mean gives us the center of the values we want to simulate. If the mean number of registrations is 165, the generated values should generally cluster around 165. The standard deviation describes the amount of spread around the mean. A smaller standard deviation keeps the generated values closer to the average. A larger standard deviation allows the generated values to move further away from the average. These two values work together. The mean tells Excel where the center should be, and the standard deviation tells Excel how much variation to create. We obtain these values from our summary statistics for our sample data that we create. Now, these two distributions you see on this screen have the same general center. The difference is the spread. Um, the distribution with the smaller standard deviation has values concentrated closer to the mean. The distribution with the larger standard deviation covers a wider range, and this affects the predicted outcomes. Inputs with greater spread usually create more variation in predictions. Two simulations may have similar average results and very different levels of uncertainty. And this is why the simulation mean should always be discussed along with the standard deviation range and the histogram. Again, the simulation mean should always be discussed along with the standard deviation range and histogram. Now, why simulations use many trials? One random trial tells us almost nothing about the overall pattern. A small number of trials may be heavily influenced by outliers. An outlier is like an unusual value or something like extremely outside of the norm. As the number of trials increases, the distribution becomes more stable. So, with 1,000 trials, we have enough observations to see the center spread and the general shape more consistently. And running more trials does not fix a poor model or incorrect assumptions. It gives us a better view of the results produced by the model and assumptions that we selected. Now, the quality of the simulation, it still depends on the quality of the data. Regression models, the data, the regression model, the means, the standard deviation, and the formulas. It takes a lot, and you have to pay a lot of attention to detail. Now, this table shows what happens in each trial. Trial one has one possible registration value and one possible marketing value. Those values are entered into the regression equation, which produces a predicted revenue. Trial two uses a different combination and creates another prediction. The same process continues through all the rows. The big thing here is that the regression equation remains fixed. The intercept and the coefficients do not change from trial to trial. The inputs change and the predicted outcome responds to us changing our inputs. So by the end of the simulation, we have many possible predicted revenue values. And this is an example of those for the Monte Carlo simulation. Now, once the simulation is complete, the predicted values form a distribution, and some outcomes will be lower, many will fall near the center, and some will be higher. We want to see where most of the outcomes are concentrated and how far the distribution extends in each direction. We want to check whether the distribution looks fairly balanced or whether it has a longer tail on one side. The distribution, it doesn't identify the one outcome that will occur. It shows the range and pattern of outcomes produced by the model under the simulation assumptions. Now, summary statistics gives us a numeric description of the simulated outcomes. The mean is the average predicted outcome across all our trials, and the median is the middle value for the predictions that are placed in order. The standard deviation describes how widely the predictions are spread around the mean. The minimum is the lowest simulated prediction, and the maximum is the highest. The range is the difference between the maximum and the minimum. Read these measures together. The mean tells us the center, the standard deviation and range help us understand the amount of variation around that center. And remember, you can't just look at one of the numbers, you have to put it all together. Now, what is a histogram? A histogram, it's a visual summary of numeric data. It groups the predicted outcomes into ranges and counts how many trials fall into each range. The horizontal axis shows the frequency, excuse me, which is the number of simulated outcomes in each interval. And the bars touch because the ranges are connected along a numeric scale. Now, a histogram helps us see information that may be difficult to understand from a list of 1,000 values. We can quickly identify the center, the spread, the shape, and the less common outcomes in the tails. So, how to read a histogram? When reading a histogram, start with the center. Look for the section where the bars are the tallest. Um, this is where the outcomes are more concentrated. Then look at the spread. That's going to be how wide it is. A narrow histogram shows that predictions stay closer together. A wide histogram, it shows greater variation. And now look at the shape. The distribution may appear fairly balanced, or it may extend further on one side. Here. Finally, examine the tails. The tails represent um, the common low and high outcomes. The histogram and the summary statistics should support the same general interpretation. Now, what if analysis versus the Monte Carlo simulation? The what if analysis and the Monte Carlo simulation, they answer different questions. The what if analysis evaluates the selected values. We choose the input to change and then calculate one predicted result from that scenario. Now, the Monte Carlo simulation, it evaluates many generated input combinations. The output is a distribution of predictions. Scenario analysis is helpful when a business has specific alternatives under consideration that they want to test. Simulation, it's helpful when the business needs to understand variation and uncertainty. And these tools work together. They work well together. The scenarios compare the defined choices, and the simulation provides a broader picture of the possible results surrounding the model. Now, the expected income and the risk information serve different purposes. The simulation mean gives us the average predicted result across the trials. The standard deviation tells us how widely the simulation predictions may vary around the average. In our example, the mean is about $36,840, and the standard deviation, $2,650. The mean helps us understand the center of the distribution, and the standard deviation tells us that individual outcomes may fall above or below that center. And a decision should consider the expected benefit and the amount of variation the business may experience. Now, a recommendation should follow the evidence produced by the analysis. It should use the numbers in the analysis. So you begin by stating the option you recommend and then include the predicted result for that scenario and compare it with the baseline. Next, explain the cost or the operational requirements connected to the decision. Include the simulation evidence by describing the average result and the amount of variation. Finally, state any important assumptions or limitations. The recommendation should answer the business question directly. The audience should understand which option you selected, why you selected it, and what uncertainty still surrounds your estimate. Again, the recommendation should answer the business question directly. You need to know what you selected, which option did you choose, why did you choose it, and what are the limits? So, kind of like what you see here on the screen, the recommendation. What do we do? Why do we do it? And what are our limitations? Now, a model results, um, the model results are estimates. The quality of data affects the accuracy of the regression model. Missing, incorrect, or incomplete data can affect your prediction. They not can, they do affect your prediction. The model may also leave out factors that influence the outcome. Business relationships can change over time as customers, markets, costs, and operations change. Remember COVID. The simulation results depend on the assumptions entered into the worksheet, including the means, the standard deviations, variable types, and distribution formulas. So use words like predicted, estimated, expected, and simulated. These terms communicate the evidence accurately and keep your interpretation realistic. Now, um, here we summarize some issues that can affect your analysis. The coefficients must come from your current regression output. The changing cells, they must contain the inputs, and the result cell must contain the prediction formula. The variable type must match the data. Counts should produce whole numbers, and continuous amounts may include decimals. The means and your standard deviations must come from the correct variables and the correct sample. During interpretation, remember that the simulation mean is an average across trials. And The recommendation should consider cost, feasibility, business needs, and uncertainty along with the predicted results. You need your predicted results. All right, time for a demo. We've covered the concepts and now we're going to apply the process in Excel. And during this demo, I'm going to work through the full sequence from the data to the final interpretation. The spreadsheet example it'll use a different example from what I went through here, but you're going to be able to see the process, see that the process transfers to other situations. And pay attention to where each number comes from. The regression coefficients, means, and standard deviations will be used again later in the workbook. So the Excel steps make more sense when we understand how the outputs are connected. Now, let me pull up my Excel file. Okay. So first, I'm going to be using another fake business that I created. Hold on, and my mouse has gone away. So, there it goes. All right. So, um, in this one, I am using a fictional pet care business for this demonstration. And the workbook is going to follow a standard sequence that can be used with many different data sets and business questions. Now, my business is Paul's and Pat's Pet Care, and they want to predict the monthly service revenue. Um, they want to predict their monthly service revenue. And so monthly revenue, and I'm going to make my screen a little bit bigger so you can see that. Monthly revenue in this case is our outcome. It is what we are trying to predict. And then we have appointments booked and marketing spend are our two inputs. And we're going to use these same variables all the way through our regression, the what if analysis, and the Monte Carlo simulation. So the business is comparing two choices. The first choice is a 12% increase in appointments booked, and the second is a choice. The second choice is an additional $750 in marketing spending. We will compare both choices with the current baseline. And I'm going through the complete Excel sequence from the original data to the final recommendation. And the data and scenarios you see here, of course, I made them up. But the process can be used. So let's see. I am having trouble with my mouse. Okay, our first thing we're going to do is we're going to randomize our data because we want to make sure that we're testing with a random set of data so that we more accurately can represent our data. So I need a random set of 100 rows of data. So what I'm going to do is I'm going to create a column here called rand, and I am going to enter the formula for rand here. And what this does is it keeps, you got to start with an equal sign, sorry. Equals rand, and then I'm going to put this here, and it generates a random number. So notice this is 0.8493359. Watch what happens when I'm going to click in this bottom right corner, and it's going to fill down throughout my data. the formula and create a random number. See, I did that. But do you notice this number in the first block changed? It changed. So random, whenever you do things with the cells, this random value will change. So in order for us to actually sort our data, we're going to need to make a static row of data. So what I'm going to do is I am going to click this and I am going to hit Control C and I'm going to click this and I'm going to have the paste options, but I'm going to paste values. And so notice when I hit paste, these numbers changed again. So we don't want the equals ran to remain in our cells. So I have the random values in the next column. So I'm just going to delete the column with the formula in it. And I thought that would move my data over. There we go. And notice there's an actual volume. So the next thing I am going to do is I am going to sort my data. And to do that, I'm going to go to the data tab and I am going to go to sort. So this is my sort window. I am going to sort by my random. And notice I have this checked. My data has headers because my data does have headers. I'm going to sort by smallest to largest and click OK. So notice that it sorted my numbers and there are real numbers in this field and they are sorted. So the next thing I'm going to do is I am going to copy 100 rows of data. I don't need the random, but I am just going to copy 100 rows of data. And since my data has a header, I actually do have to come down to 101 to get 100 rows of data. So I copy it, I go into my random sample, and I'm going to make this view big also. And then I am going to paste it in. And I'm not going to do that. I'm going to actually just click this top one here because I don't want another header row. All right. So now I have copied in my data and created my random sample of data. And this random session sample sheet is what I'm going to use for the regression and the descriptive statistics. And I'm going to take a drink. All right. And we're just going to confirm that we have exactly 100 rows, and we do. All right. Now, next thing I'm going to do is run a multi-regression model. So on this screen, I am going to go to my data tab. I have this data analysis tool here, and I am going to click it. And then I am going to go to where is my regression? Here, regression. I am going to choose regression and I'm going to click OK. And the next thing going to do is select my input range. So remember that the monthly revenue is the value I am predicting. So it goes in the Y range. Marketing spend and appointments book are the two inputs. So they're going to go into my X range. So I am going to select everything in my monthly revenue all the way down to 101. And that is my Y range. For the X range, I am going to select everything in our two columns here. And the next thing, I want to make sure that I have this, since my data does have labels and headers, I am going to select this. The next thing is I want everything to generate in a new window. So I'm going to name that new window, and I'm going to name it multiple regression model. All right. And I don't know why it's still clicking things. Looks like something's wrong with my computer. So I'm going to write that again. Okay. So I'm going to click OK. And voila! We have a new tab that says multiple, that's called multiple regression model. And here you see our regression model. Remember when you turn in your work? This is what the regression model should look like. Now, I'm not going to go over everything here. I'm just going to go over the values that we need. And for our simulations and our scenarios, we're going to need these simulations, these coefficients here. Okay, so I'm just going to copy that because that's what we're going to be needing. Now, we'll need, uh, next thing we're going to do is we're going to generate our summary statistics. Um, to do that, we're going to go back to our random sample tab and we're going to choose, scroll back up to the top. I'm going to choose data analysis and then I'm just going to choose descriptive statistics. Um, I'm using the same 100 record sample to create dis- the descriptive statistics I selected for the variables. So my range here, I'm just going to select all of my data and bam. It's in columns. It's grouped by columns. And I have labels in the first row, so I'm going to do that. And I am going to name it summary statistics. Okay. It's going to go into a new worksheet. All right. It told me to please choose something. What did I not? Oh, I have to click summary statistics because that's what I'm actually going to be creating. So Um, and it created it. I'm going to make it a little bit bigger. I'm going to select everything and double click so that we can see everything, and it didn't do it. So we'll just click it and make it so we can see it. And we only care about a couple of things on here, and that's our mean and our standard deviation. So what we need are going to be this row and this row, our mean and our standard deviation for each of our variables. And I'm just going to highlight them so you can actually see what I am talking about. We generated our means for each one of our input variables and our um mm, and our standard deviations. And if you want to see it for the monthly revenue, we have it there too. Now, um next we're going to do is we're going to create our what if analysis. So there is a tab here for the what if analysis. And we're just going to fill it out, okay? So, um what I'm going to be needing is going to come from our regression model, and I'm going to need our coefficient. So I'm going to copy this data and I'm going to come to my what if analysis and I'm just going to paste it in because I'm going to need it. So here, The first thing that I'm going to do is I am going to replace this B2, which is our starting value. And I'm going to replace this with the sample mean for our appointments booked, which means I need to come to my summary statistics and I need to copy these values. So I'm just going to copy this part because that's the part I only really care about right now. So I am going to paste that in here and I am going to go back because I need a little bit more. I kind of need to know what the columns are. So I am going to go into this what if analysis and I am going to put that there. So enter the sample mean for the appointments booked. Appointment books, the mean is here. Control C, here, Control V. Enter the sample mean for your marketing spend. Control C, here, Control V. Okay, now, mm, now let's work on the proposed changes. So here, we're going to test an increase of 12%. So we have to put the formula in here, and that's going to equal our starting value, and we're going to multiply it by 1.12. And that's how we increase our value by 12%. And our proposed change for the marketing spin, we're going to say it's equal to this. And we are going to, okay, I am back. So for the proposed change for the marketing spend, we're going to increase our marketing spending by 750. So we have equals our starting value, and then we're just going to add 750 and hit enter. So these are our proposed changes for our our what if analysis. Now, here we're going to enter in our equation for our prediction. And I am going to put the actual formula here so you can actually see what our formula will be. But I'm also going to put it here and put in the values. So our intercept is going to be this $3,912 here. And let's see if it'll help let me copy the value. It does not. So I'm going to copy that and I am going to see if it lets me paste that. It does not let me paste that. But since we're only doing this one time, I'm just going to replace it with the sales. So our intercept, I'm going to highlight that and I'm going to click the intercept. Our appointments coefficient, I'm going to highlight that and click here. And our marketing spend coefficient. I am going to highlight that and click the coefficient. Now notice that I did not hard to code the values in this what if scenario that we're doing right here. When we get to the Monte Carlo, you will need to enter in the values manually. You cannot use the cell references because well, you can. There's a way to do it, but it's easier if you just enter in the actual values. So, that is our formula that we are going to be using, and I am going to hit enter, and we have our predicted value. Okay. So the next thing we have to do is create our two scenarios in the scenario manager. We already have our prediction formula. And for the first scenario, B2 right here, this is going to be our changing cell because it contains the appointments booked. And the scenario value comes from C2, which contains the 12% increase. For the second scenario, we're going to have B3 is the changing cell because it contains the marketing spend, and the scenario value comes from C3 here, which contains the baseline plus 750. C2 and C3, they're going to hold our proposed values. B2 and B3 are the model input cells. So those are the cells the scenario manager changes. B5 is the result cell because it contains the regression formula. And I am going to make that green so you can see it. I don't like that green because it's hard to see. All right. So what we're going to do is we're going to go to our data tab, and here in data tools, I'm sorry, here in forecast, we have this what if analysis. And I'm going to click it and I am going to go to the scenario manager. Remember the other what if analysis tools that are available? You see them here also. But today we're going to be using the scenario manager. And when I click it, it pops up this screen. And I am going to add a new scenario. First thing I have to do is I have to name my scenario. And I am going to name my first scenario. I'm going to name it increase appointments booked by 12%. Okay. Now the changing cell for this is I am just going to click here and I'm going to click the cell. All right. Comments, you can just ignore the comments. Then um I am going to click OK, and it's going to take a little bit, but another screen is going to pop up for me to enter in the value that we have here in C2. So I am just waiting on it to happen. Ah, I clicked and it came. So the value that we're going to be changing, it's going to be this 156.0832. And I am going to click OK. And then I'm going to add another scenario. And we're going to call it, yeah, what do we call it? Increase marketing by $750. The changing cell for this one, I am going to click the um the B3 cell, and then I'm going to click OK. We have a box that pops up, and I'm going to type this 3978.84 into it, and then I'm going to click OK. All right. And now we are going to r- run our scenario summary. And to do that, I am going to go to summary, and it pops this up. I'm doing a scenario summary. Um, and my results cell is going to be here. This is where our prediction formula is, this green cell here. Notice your cells, if you're following along, you may not have a green cell. And then I am going to click OK. And voila, we have a um, scenario summary. Okay, I'm going to make this bigger so you can actually see the results as I explain them. So this is the scenario summary that was generated, and it compares our current business conditions with the two proposed changes. The current value columns, this is our baseline here. That's what our original prediction produced. Um, so the baseline uses an average of 139.36 appointments and a marketing spend of 3,228 dollars and 84 cents. And with those inputs, the regression model predicted 28,000 and $173.62. So the first scenario, we increased our appointments by 12%. And we kept the marketing the same. Notice here what's highlighted in gray are the values that changed in our scenarios. Okay. The model predicts the monthly revenue of $30,000 and 443 if we increase our appointments by 12%. So that's an increase of about 2,200. Um, uh, uh, that's an increase of about maybe 2,000. Um, dollars over the baseline. And the second scenario increased the marketing by $750. And so the market spending increased by the market spending increased. Um, this does this does not seem right. Increased our appointments by 12%, increase our marketing spending by $750. I may need to go back. Oh, yeah, it's right. So we increased our market spending by $750. I had a brain freeze there for a second, okay? Um, and our market spending, it increased to it increased about a our not our market spending, but our prediction increased about $1,200. It increased for by about $1,200. Um, Again, the gray cells show which input changed in the scenario, and the other inputs remained as they were in the baseline. And it allows us to examine the estimated effect of each proposed change separately. Now, based on predicted revenue, increase in appointments produces a better result. It generates about $1,000 more in predicted monthly revenue than the marketing scenario. The business has to also consider staffing, scheduling, and operating capacity required to serve the additional appointments. But based on the model results alone, the appointment scenario is the recommended option. But that's based on just this model. All right. Now we're going to go through a Monte Carlo simulation, which I already have set up here. So, here for scenario, for this summary, um, we're going to work on our two defined choices. We're going to move from the two defined choices to and I'm going to make this a little bit bigger so you can see it. Cancel. All right, all right. So we're going to move from the two defined choices to a range of possible values. And I need to tell this template what type of variable each input is. So appointments booked, it's a discrete because it is a count. Um, so here I am going to choose discrete. And notice these don't have values because they can't calculate because I haven't filled this whole thing out. And for the marketing spin, I am going to choose continuous. Still don't have calculations, but that's okay. So I'll need the mean and the standard deviation for this. So I am going to come back to this and I am going to copy all of my cells I have here because I'm going to need it all. So in our Monte Carlo simulation, I'm just going to put those here. And I'm going to take this and move it and put it underneath just so I can see it all on one screen or you all can see it with me. So the summary statistics mean for the apartment booked. I have the mean for apartment books is here, 139.36. And I'm going to see if it lets me copy this. It does. And the summary statistics for this is going to be this value. I'm sorry, the standard deviation. I'm going to copy that and I'm going to put it here. All right. And notice that this field automatically generated our numbers for our simulation for the appointments booked. And now I'm going to work on marketing spend. I am going to find our mean. I'm going to copy it. I'm going to put it in this field here. And then I am going to find our standard deviation and I am going to put it in this field here and notice it all populated. And now I need to work on let's see, I need to calculate the model predictions. And here, not sure why there's a control here. I'm not sure what to do, but in this D6 cell, I'm going to use the same regression equation again. The intercept and coefficients, they are going to stay the same because the model has not changed. The cell references, they're going to point to, we're not going to use these, but I'm going to actually hard code the values because it'll be easier for you guys to understand. But I am going to show you the equation I am going to be using. I'm just going to put it right here so you can see it. Okay. Um, I'm also going to copy it here because I'm going to put it in here. So I'm going to replace these values. I have the intercept here. Um, Trying to figure out an easy way to do this. I come back to this value. I am going to replace the intercept with my intercept value 3912.797574. I am going to replace our coefficient here with 135.736781. And I am replacing the marketing spend. Notice I'm hard coding these because I'm going to fill this formula down and I don't want these values to actually change. So my marketing coefficient, I'm going to put that as 1.6552522146. And then when I hit enter, we get our predicted value. Okay. Now, I'm going to fill this formula down to the end by clicking in the right corner. And when I do that, all of the predicted values came up. Okay. And notice that we got predictions in this tab for 1,000 different test values. Okay. Are, yeah, different test values, but also it it actually created our Monte Carlo, excuse me, summary statistics here. So the difference I want you to keep in mind, the scenario manager, it only gave us one prediction, but the Monte Carlo simulation, we were able to easily predict many, many values, okay? Now, we have our summary statistics here and it updated automatically. I don't need to run a descriptive statistics again because the formulas are already in this template. The average, it's the mean of the 1,000 simulated predictions. And if we, let's see, it's the mean of the 1,000 predictions. And the median, that's going to be the middle prediction after we put the results in order. And notice that they're kind of close. And when the mean and median are close, the distribution is usually centered in a similar area. Now, the sample standard deviation that we see here, this describes how widely the simulated predictions vary around the average. The minimum and the max, the minimum is going to be the lowest prediction, and the max is going to be the highest prediction. And the margin of error that we see here is used to create the 95% confidence interval shown below. The lower and upper bounds give a range around the simulated average based on the output of this run. So, if we were to recalculate our RAND and resort with new input values at the very beginning, all of these numbers you see in here will be different. So every time you run this with a different data set or a different sample, your numbers will be different. But and that's expected. I'm looking for the overall center and spread of the results. And just remember the min and max are not the automatic guaranteed worst case and best case scenarios. Um, they're the lowest and highest values that we generated in our trials. Now, the next thing we're going to do is we're going to create a histogram so that we can kind of interpret our data. So what I'm going to do is I'm going to select all of our predictions all the way to the bottom, okay? And the next thing I'm going to do is I am going to come to our insert tab And there's a couple of ways I can do this. I can either go to recommended choice charts, or I can go here to the statistic chart, and I can choose histogram. Um, and I'm going to choose a histogram. Or I can come to the recommended charts and go to all charts, and I can go down to histogram here. So I am going to choose a histogram. Um, I'm going to move the chart somewhere close to the side so we can see it here. I'm going to rename the title because we always want to have a great title. And I'm going to call it Simulated Monthly Service Revenue. And I'm going to give it axis titles. To do that, I'm going to click this plus here, and I'm going to click axis titles, and I'm going to type here at the bottom. Um, what do I want? I think I want our monthly revenue. And here I am going to call this our frequency. Okay, now let's see. Okay, so what do we see in this histogram? And I'm going to close this on the side so we can actually see it. And I'm going to zoom in so you can see the histogram a little bit better. This histogram shows the distribution of our simulated monthly service revenue values. The horizontal axis here, we see our predicted monthly revenue, and the vertical axis shows how many simulations trials fell within each range. Most of the outcomes concentrated in the middle of the chart, generally between 24,000 and about 33,000. Um, and the highest bars appear to be around 26,000 to 30,000. So the revenue ranges occurred most often, those revenue ranges occurred most often in our simulation. Now, this distribution, it's kind of bell-shaped. The bars rise gradually towards the center and then decrease towards both ends. And that indicates that the values near the center were more common, while very low or very high revenue outcomes, they occurred less frequently. And the full set of simulated results, they range between about 15,000, well, 14,000 and something, but it's almost 15,000 to about 39,000. And this spread represents the uncertainty and the variability in predicted monthly revenue when the appointments booked and the marketing spending change across our simulation trials. And this histogram, it gives us a visual picture of the risk. The center shows the more common predicted values or outcomes, while the ends um, of the chart show less common lower and higher values or higher results. And because the simulation uses random values, the exact bar heights may or they will change if Excel or someone else runs this analysis, but the overall distribution, it should remain similar. Okay, so now we need to compare our results. So I'm going to start with the scenario summary. Um, Look at the baseline. Uh, we're gonna look at the baseline and mm, okay, yeah. The what if analysis, it compared our two specific business choices, and the baseline predicted the monthly revenue is $28,173.62. Now, when appointments increased by 12%, the predicted monthly increased to $30,443, and that's an increase of about $2,200 over the baseline. And when market spending increased by $750, the predicted monthly revenue increased to $29,415. And that's an increase of about $1,241. Now, the appointment scenario produces the largest predicted increase. It generates approximately about $1,000 more predicted revenue than the marketing scenario. Now, comparing those fixed scenarios with the Monte Carlo simulation, which we have here, and I'm going to go up. Well, I guess I should have brought my um chart to the top, and I wonder if it'll let me do that. Not sure how to move it, but we'll get figure that out later. So if I look at my Monte Carlo simulation, the simulation average is $28,000.40, and the median is 28,152. Um, Both values are close to the baseline prediction of $28,173. So it makes sense because the simulation generated appointment and marketing values around the same means used to create the baseline. So as the inputs move above and below the averages, the predictions also move above and below the baseline, but the standard deviation is about $4,000. And this shows us a meaningful amount of spread in the simulated revenue predictions. The simulated results range from about 14,000 to $40,000, and values near the center occurred more frequently, while results near the minimum and maximum, they occurred less often. And so our confidence interval, it ranges from approximately $27,866 to about $28,375. And this interval describes the estimated location of the average simulated prediction. The histogram and the standard deviation describe a wider variation among the individual simulated outcomes. So, based on the what if analysis, increasing appointments is the preferred scenario because it produced the larger predicted revenue increase. The simulation shows that actual revenue may still vary because appointments and marketing spending change across possible business conditions. So the final recommendation is to consider the appointment strategy that we did in the what if analysis, while confirming that the business has enough staff, schedule availability, and service capacity to support um more changes. Where is, sorry, my scenario summary. Um, so the final recommendation is to consider the appointment strategy. Okay, so that completes the process. We started with a full data set. We created, I don't know where our full data set is or where it went. Probably because I have something hovering over it. So we started with a full data set, and then we created a random sample of our data with only 100 rows. And then we ran a regression model so that we can get our coefficients, our intercept and our coefficients, so that we can create our prediction formula. Remember that our prediction and formula was very important here. And then we created summary statistics on our random data set so that we could get the means and the standard deviations. And remember that if you run this whole process again on the same data, these numbers will differ because you're going to use a different random set. Now, um, and then we ran our what if simulation here, which created our scenario summary. And after that, we ran our Monte Carlo, where we compared our um, numbers here with our Monte Carlo um, to see, what the meanings are, and really looked at where most of these values fail. And because this that predictive value here was more, we chose this one. And we do have limitations because we still have more to consider in the variability. Like, can we actually support this as a business? So, um, that is our simulation. Thank you so much for joining me in this long presentation. You have a good night or day or whenever you're watching. Bye.